Okay, so let's start. We're in section 4.8. Let's just randomly pick number 3. I don't think I've done number 3 yet, so let's just randomly pick number 3, finding a distance. Now, some of these, the author of the book actually drew the picture for you. I will not be drawing any pictures for you on your tests and quizzes. You will be responsible for generating your own picture. So, it's a beautiful lighthouse and stuff, but I'm not going to look at that right now. Here's what's happening. The angle of depression from the top of the Smoketown Lighthouse, 120 feet above the water. So here's the lighthouse, here's the water, that's 120 feet. The angle of depression to a buoy, out here's the buoy, is 10 degrees. Now, we just talked about that. Angle of depression. Angle of depression. Start out looking straight ahead. Pretend you're the guy up here in the lighthouse. You start out looking straight ahead. Now you're going to look down at the buoy. So your angle of depression is 10 degrees. Start out looking straight ahead. Either look up or look down. That is your angle of elevation or depression. So this is your angle of depression. Notice it's not even in the triangle. So it doesn't do me any good out there. I need to get it into the triangle. Well, there are a couple of different ways you can handle that, right? What could you do with that 10 degrees? Okay, not minus 180. Minus 90 maybe? This right here would be 80 degrees. Would you agree with that? So you could do that. What else could you do? Recognize that that angle and this angle are what we call alternate interior. So if that's a 10, this is going to be a 10. That's personally the way I always do it, but it's completely up to you. If you want to use that one, it's 80 for sure. Now here's the deal. If you think about it, if you're a man in the lighthouse looking down at the buoy, or if you're a seagull sitting on the buoy looking up at the man, your angles are the same. The angle of depression will always match the angle of elevation. Always. Always, always. Okay, so what was the question? How far is the buoy from the lighthouse? Where do I put the X?
On the hypotenuse.
The X is not the hypotenuse.
Oh,
The X is right here. How far is the buoy from the lighthouse? So if you were the seagull sitting on the buoy and you were going to swim to the lighthouse, how far would you have to swim? That's right there. That's X. That's X. All right, so what function? What function? Sine, cosine, tangent? It's going to be another tangent problem. So the tangent of 10 is 120 over x. So x tan 10 equals 120, and x is 120 over the tangent of 10. Now you should already be set in degrees from that last problem, so I don't need to caution you about that. But what do you get? Always make sure you're in the right mode. My book says 680.55. Is that what you got? All right, let's pick another one. Ooh, number 14 looks interesting. While hiking on a level path toward Colorado's Front Range, Otis Evans determines that the angle of elevation to the top of Long's Peak is 30 degrees. All right, so Otis is hiking along. Here's the mountain. He observes that if he looks up to the top of the mountain, his angle of elevation is 30 degrees. Everybody okay with that? All right. moving 1,000 feet closer to the mountain. So moving 1,000 feet closer to the mountain. Otis determines the angle of the elevation is now 35 degrees. How much higher is the mountain than Otis's elevation? Any thoughts on this? This is a little trickier. Any ideas? What? Well, you could call this X, and then the whole thing would be X plus 1,000. We could do that. Actually, I can't call that X. I have to call a different letter because I already have an X there, so I'll call it Y. Would you agree that the tangent of 35 equals X over Y? Now you can't solve that, but is that a true statement? Would you also agree that the tangent of 30 equals X over 1,000 plus Y? That's not solvable either. But what I have here is two equations with two variables in them. Have we ever done anything like that before? Substitution or elimination. That's what we're going to do. We have a system of two equations. Each triangle, the little triangle and then the whole big triangle, gave us an equation. So now I have two equations and two variables. So I'm going to go ahead and get rid of that fraction. So y tan 35 equals x. And y plus 1,000 tan 30 also equals x. Would you agree with that if I multiply the y over here and I multiply the denominator over here? Now, if they're both equal to x, then they are equal to each other. So I can say y tan 35 equals y plus 1,000 times tan 30. Everybody still with me? Now, I've got to get y by itself. So I got to get all the y's on the same side. So I'm going to go ahead and do my distributive property over here. So I have y tan 30 and 1,000 tan 30. I'm just doing the distributive property. I'm going to move all the y's over on the same side of the equation. If I'm going to solve for y, I can only have one. So I'm going to get them on the same side. You still with me? Now, what do you think I'm going to do if I have to get just one y? What could I do here to get just one y? How about factor it out? If I pull out the y, then I'm going to have tan 35 minus tan 30 in parentheses. And now, Anna, I will divide. Now I'll take 1,000 tan 30 and divide it by tan 35 minus tan 30. Alright, so let's go back through those steps. Then we're going to go to our calculator and actually type it in. But let's go back through those steps and make sure everybody's with the program here. Alright, so we started with these two equations. We wrote an equation for the little triangle. Tan 35 is x over y. Wrote an equation for the big triangle. Tan 30 is x over 1,000 plus y. So we have these two equations. I got rid of the fraction in both, so that left me with this. And when I got rid of the fraction in both, the equations were both equal to x, so I set them equal to each other. Then I did the distributive property and put both y's on the same side of the equation. Then I factored out the y and divided. Alright, you've done that process before, not with tangents, but you've done that thing before when you found the inverse of functions. Alright, so now we're ready to type it in. Notice I kept these parentheses here because they are necessary when you type it in. I'm changing my calculator to degrees. Now I'm going to do 1,000 tan 30. And then divide by parentheses tan 35 minus tan 30. I got 4699.35783. What about you? That's what you got? Now be careful, because we just did all that work and we just found y, which is awesome. But what was the question? X. So I'm going to come back up here. And what do I know about x? What's x? It's y times the tangent of 35. So I'm just going to say times tan 35. And that is 3290.53 feet. Now, in a little while, a couple weeks or something, we're going to be able to do this problem in a totally different way. Did you notice this little triangle out here? We're going to be able to use him after some time here. We're in chapter 5. We're going to learn how to use him. Why can't I use that little triangle right now? It's not a right triangle. Yeah. So right now I'm restricted to right triangles. But when I get a little bit more experience, we'll use him and we'll solve this problem in a totally different way. Not totally, but a different way. Okay? All right, let's try one. What time? Okay, I don't have time to do another one. So I'm going to stop right there. And what happens tomorrow? We have a quiz, one problem, not over this. One problem, something like what's the cosecant of the angle whose tangent is 5/8, something like that, right? And everybody's going to be able to do that. Not going to take very long. We will work some more on word problems tomorrow. So